Yeah, so the recording has started. So for anyone who's watching this on YouTube, every, I mean, every live session, you will find it at this channel. And as far as the code is in question, you will find it at this repository. So I'll maybe pin it in the comments or something. So you'll find the code here. And if you're watching it on YouTube, the subsequent sessions will also be posted here. So you'll be working on Colab. So to use Colab, go to your Google Drive and create a folder where you will store all of your files. Click on new, go to, yeah, click on new, go to more and create a Google Colab.
Hello, sir. Can you hear me?
Yeah.
Yeah, I'm just saying, is R program or Tableau program? This is very much essential for data analytics.
For this course, no.
No.
In general, maybe not for this course.
Okay, this is not required.
No, because the title says with Python, right?
Okay, sure.
Yeah. Yeah, so we'll be using Colab. The reason is in your lectures, I saw that you were using Anaconda. So Colab is built on top of Anaconda. And the second thing is it is independent of your operating system. For example, I'm on a Mac. Some of you may be on Windows, some of you may be on Linux. So a Colab doesn't use your hardware, it runs on Google's hardware. So all of us will be using the exact same hardware, so everything will run the same. And you won't need any installations because the libraries are pre-installed in this case. So I request all of you, to work with me in parallel. You should also have a Colab notebook because I'll be giving you questions. And assuming you have seen the lectures of the first week, you should be able to attempt the questions. So we'll be working with the same data set that was in your lectures that, let me show you. We'll be working with this data set where you have country, year, population, continent, life expectancy, and so on. So for working with a data set in Colab, you first need to upload it because again, it's not using your hardware, it's not using your storage basically. So
This
you,
data, sorry to disturb you.
yeah.
This file I was not able to download, in fact, CSV file.
Oh, it was not provided in your, lectures.
It was,
Let me, yeah, let me share it. Let me share it. No issues.
please.
Yeah, let me share. Does not allow sharing files. Yeah, you clone the repository because it would be empty as I haven't added anything yet. After every session, I will add the question that we discuss in that session. This is the first session. For the earlier question, for yesterday's lecture, actually, there will be multiple sessions and every session will go in its own path. For example, we won't be in sync. You have to choose which sessions you have to follow, either with me or with the other person. Yeah, so can you access this data set? Load it into your Colab so that we can proceed. Once you are done, maybe raise your hand.
So I'm supposed to open Google Colab from the
browser.
Google
Yeah.
Drive.
I mean, you go to
How-
your browser. Yeah, you go to your
yes,
browser, then to your Google Drive, and just create a new collab.
I wasn't able
Yeah,
to do that in the new section. Can you show me once?
Yeah, just a minute. Yeah. So you go to
Thank
your
you.
browser, let's say, go to your Google Drive, and anywhere where you want to store your notebooks, new, more, Google Colab.
I'm not getting that option to go off Google Colab.
You're not getting the option for?
Google Colab.
I don't know. It should be there. So do you see it in more? If you press on more, don't you see these options?
In more, there's no Google Colab in me. Like I can see the rest of the options, but not the Google Colab.
Okay, so at the end of the session, remind me. Maybe we'll speak one-on-one.
Oh, okay.
in Colab, I am opening this untitled 0.IPYNB. This I
Yes.
have to open.
Yes.
Okay.
Okay, so only 2 people have raised their hands.
Sir, can you please send the GitHub link again, sir?
Yeah, if you access the chat, you'll find it. I'll
Sir,
share it
actually,
again at the end of the session. No issues.
Sir, I joined lately, so I can't find the link, sir.
Yeah, I'm saying
I can only find the drive.
I'll reshare the link at the end.
Ah, okay, sir. Thank you.
Hmm. Okay, so 6 people are done.
I could also open it.
Hmm?
I have also opened it untitled 0.IPYNB file in Colab.
Yeah. To get the option for Google Colab, click on more and add. I mean, for those with Colab not opening, can you please share the CSV file again?
Hi, sir. This is Aman Pandey. Am I audible?
Yeah. Yeah.
Sir, I've like Google has removed it for normal user, the collab sheet option. So they have to directly go to collab link. I've shared that collab link in the chat.
Can you say that again? I mean, what have they removed?
They have removed that collab sheet from Drive. Matlab, it is available in Mac, it is available in Few, but it is not available in Windows. So you have to go to Google Colab separately. I've shared the link. Am I audible?
Yeah, you're audible. Yeah.
I've shared the link in the chat. Collab.researchgoogle.com.
Oh, I was not aware of it. Yeah. Thanks.
You're welcome, sir.
Yeah. So, I mean, if people on Windows have to basically manage their notebooks, what do they do?
From here, you will sign in via your Google and then it will work in a similar fashion.
Okay. So basically you sign up and then you can use the drive.
Yes, yes. But from Drive, they have removed the link for Collab. Like even if you search Collab, you won't be able to see. Either you will see Collab sheet or you will see Collab whiteboard, but you won't see this Google Collab.
Okay. Okay. Thank you. Okay, so should we proceed? Should we proceed? Yeah, again, I mean,
Yes,
speak up.
sir.
Yeah, speak up, because if I am on a different tab, I may not be able to see your messages. Yeah.
Okay,
So
sir. Okay.
yeah, so once you are in Colab, let's say you did not have this file, the way you do it, for those of you who are on Colab, you upload the data set here. So before you do anything, it's always good to look at the data set, at the raw data. Okay. So you have country, year, population, continent, life expectancy, and GDP per capita. Okay. So as is, you import pandas as PD. I mean, this is how you run it normally. For example, I will say print hi. You can either click on the play button or you can hit shift enter. Both work. So now that you have pandas, we want to import this data set into memory. So what you do is pd.read_csv. I mean, you've done it in your course. So let's say we store the path. Say we do this and then df.head. So we have received this country and so on. It is also better, for example, if you have data like this and the first row is the header row, you can also, it is best to do it like this, that is header equal to 0. In this case, I think it did it by default, but it is best to specify that I'm using the first row as my header row. In some versions of Python, it will use the first row as part of the data. So now we have the data. So try this out. Check whether all countries have data for the same years. Okay, so what does that mean? If we print maybe, let's say, more of them, we'll see that, for example, for Afghanistan, we have data from 1952 up to 2007. Okay, and every time we have a jump of 5, that is 52, 57, 62, and so on. So before we calculate any statistics over this data set, we would like to know if the same years are available for the other countries as well. Does that make sense? Does that make sense?
Yes.
Yeah. So the thing is, your data set has 1,700 entries. You won't be checking every single one of them, that is 1952 in every one of them, is 57, 62 in all of them. So I want you to ensure that all countries are using the exact same years. Now, to make the problem a bit easier, you can assume certain things. So you're given that no year is repeated. Okay, this is the only thing that you're given. The rest you have to do it yourself. Now, do you understand why repetition would make it a bit difficult? Try to think about that afterwards. So it's, I think, 7:20. Let's wait till 25. Let's see how many of you are able to do it. If all of you are done, then we'll go forward. If you're facing any problems, we'll see. So try it out. My camera is on. Shubham. So when you're done, please raise your hand, okay? So that I can get an idea.
Can I share my screen with you?
Why would you need that?
Because I am not able to get the screen which you are showing, how to reach there and upload the data. I think somewhere something I am doing wrong.
Can you maybe wait till the end of the session? Maybe we'll
Hello.
fix it. Yeah,
Hi.
if multiple
I
people
think
are.
there is a unique function in the Panda.
Hmm?
Unique function in the Panda for getting the unique values.
Yeah.
So we can use that.
Yeah, you can use any function you like. You can search the web. You are allowed to search the web. I mean, ideally, I will give you questions that would use material that you've already been taught. You won't be using something that you don't know. Yeah, you should not post your answers in the chat because then it spoils the fun for others, right? So you wait for the time to end, then maybe I'll ask you for your answers and we can discuss the pros and cons.
If I am working, sorry, if I am working with the Jupyter, then I have to switch over to this Google Colab, isn't it? That will be convenient.
No, you can basically use any Jupyter notebook that you prefer. I had preferred Colab because I thought it would be independent of the system, Mac, Linux, and for example, this because Anaconda requires installation, Python installation, and library installation. So I thought maybe Colab has everything pre-installed, so why not use that? You are free to use VS Code. You are free to use Jupyter Notebook if you're comfortable with that.
In fact, I'm not comfortable as on date, but I want to become comfortable with them.
No, I mean, if it is set up, if it works, that's it. Yeah.
Okay. I will wait till end, then I will discuss.
Okay.
Share with
Okay.
my. Okay, thank you.
Is anyone done? No, you don't have to share your notebook or something. I will maybe ask you for, uh, the way you did it, and then maybe I will see if it's correct or not. Yes, so those who are done, please raise your hands. Yeah. So by 7:30, let's see how many of you are done, and then we can try out some solutions. Okay, it's 7:30. So Adarsh, can you unmute and explain your solution, basically what you did? Adarsh, can't hear you. Okay, so the next one, Tarun Kumar, can you explain your solution? Yeah, it's no issues, Adarsh. Maybe we'll try it next time.
Sir, I use n unique function, sir, the method.
Yeah,
df
so
here
yeah,
dot
so how
n
do you
unique.
use it?
Sir, I can't hear.
How did you use that? Let's say you have n unique. N unique gives you the number of unique elements in a, let's say, series or something. So what did you do with that?
Uh, I use the df in the square bracket. I
No, no,
give
not the
the
code, not the
problem.
code. Basically, give me the concept. That is, you had n unique. What did you do with that? You found the number of unique elements of what?
Yes, sir. Yeah, I found the unique years, number of unique years.
Okay, and then
I just found out how to take the number of unique years, sir.
but how does that answer if all the countries have the same years?
Yes, sir.
Okay, so anyone else? Paras, you had your hand raised. Okay, so Raymond, are you able to unmute rather than printing? Can you explain it to everyone? So you used unique to get the unique years from the entire data frame, okay, and then? And how do you know what the expected years are? Yeah, okay, so how do you know what the expected years are? You say you did np.unique with pd.unique and then you compared it with expected years. What are the expected years?
Expected years, I use mean function, sir.
So how do you know the expected years are 52 to 2007? Let's say someone had more years than that, or less years than that, in fact. I mean, we have the data for Afghanistan. We are computing up to, we saw up to 2007, but maybe someone has more than 2007. Then okay, so what if this list of unique years was very long? Because it seems, I mean, you inspected it by yourself manually. So if it was too long, what would you do then? Okay, so let's try to make sense of it. Yeah, I think your solution is correct, but let's try to maybe automate that. So the first thing to do is we should check if there are any null values. So for example, the question was this is yeah. So if we try it like this, so when you apply is NA to any series, it will check if the particular row is a null value or not. So if we do sum on that, it will say how many null values you have. We have 0 null values. So we are good to go using the unique function here. Okay, so now let's say we have df year and we do n unique. So we have 12 unique years. Okay, and we are given that no year is repeated, and we also know that no value is null, right? So we want to check that every country basically should have the exact same years. So one way to do it would be, for example, that n unique for the entire this should be the same as the years I have, let's say, for Afghanistan.
Excuse me.
Yeah.
सर कोर्सेज मतलब कि कोर्स काफी तेजी से मतलब कि काफी फास्ट मतलब कि रन हो रहा है कोर्स मतलब
कोर्स या फिर इस सेशन की बात कर रहे हो?
सर कोर्स की बात करो मतलब कि सर मतलब कि 2 days में मतलब 2 weeks का ही मतलब सर वो अपलोड कर दिया गया मतलब वीडियोस एंड असाइनमेंट्स.
लेकिन मतलब उसमें कोई मजबूरी थोड़ी है कि आपको 2 हफ्ते का 1 हफ्ते में ही करना है, ये इट्स सेल्फ पेस्ड राइट। तो आप 2 हफ्ते में 2 हफ्ते का कर लो, लाइक पहले हफ्ते का पहले हफ्ते में आराम से देख लो।
सर क्योंकि मतलब काफी फास्ट मतलब कि कराया जा रहा है मतलब सर।
हाँ, बट द थिंग इज the lectures are pre-recorded right, they can't be changed। आपको 1 वीक का सारा मटेरियल दे देंगे तो फिर आप अपनी पेस पे उसे आराम आराम से ब्रेक करके देख लो। The pace as such won't change right, because they are pre-recorded lectures। Right। Make sense?
तो एक डाउट है
हाँ।
सर, इज देयर अ डिफरेंस बिटवीन इसनल एंड इसएनए जो आपने यूज किया है?
I don't know if Pandas has isNull। Yeah, isNull and isNA।
So it's the same, right? Like,
Yeah, looks the same at least।
and I had also one more doubt. Why did we use the unique values to find the number of years? सबने किया था ना year का जो, हाँ, non unique करके। Why did we use that? What's the logic behind it?
Yeah, for this one।
Yeah.
Yeah, so basically the thing is, we are given that the years won't repeat, right? So in fact that can cause a different problem. For example, we have this series and we find the unique years that gives us the maximum possible a particular country can have, right? Makes sense?
Yeah, but
I mean,
we also know कि 5 years का एक difference in 2007 तक ही जा रहा है हर country का ना।
No, that's what we want to confirm।
अच्छा, we have to confirm that. Got it.
Yeah, we want to confirm whether that is the case। For example, you did not know that the years are spaced by 5 and that everyone has the same years। So you want to confirm whether it is true।
Okay।
Okay। Yeah, so there is actually still a problem in this case। Can you maybe identify that? Is this code enough basically to judge that every country has the same years?
We are only detecting the Afghanistan has all the 12 years or not. Rest of the countries we still have to check.
Yeah, for the rest of the countries, what could possibly go wrong? I mean, they can they have more years than what we have? Or can they have different years? So in this case, the problem is, let's say we have Afghanistan, let's say, I mean, for example, our years are 1, 2, and 3. Let's say, for example, 1, 2, 3, and 4. And let's say we have another country, B, whose years are 1 and 2, okay? And then we basically find the number of unique elements in this case. The number of unique elements are still 1, 2, and 3. We compare A and U, but we miss out that B does not have the exact same years. Make sense? Does that make sense?
Can you repeat?
Yeah,
like
so
A, B, and U are there. Unique, we already know that there are 3 elements, 1, 2, and 3. And we are cross-checking with A. So A is also not equal to unique.
Yeah,
B is
sorry,
also
I
not
missed
equal
4.
to unique.
Yeah, I missed 4. Yeah.
Right.
Yeah, so I was saying, let's say we had only 2 countries, 1, 2, 3, 4, and 1, 2. Okay, one has 4 years, one has 2 years. We do this check basically. We compare the total unique with the first one that is visible to us. We see that, okay, this is good, but the next country may have fewer years. It's a subset of the unique sets. So this is not a good check for that. So what you have to do is, the idea is to iterate over all the years, right? And then you make the check for unique elements. So how do we do it is, for let's say for year in, not year, for country. For country in df country. Okay, so we are iterating over the countries and we say if, and then the same thing, if df year, we can in fact save this. Yeah, so we say if total unique is equal to, in fact, even, yeah, there's even a better method. I'll show you. Yeah. So we have df, we have year, and we want to take only those which are for this country. So country is equal to country, and then we apply n unique. And we say if this is not the case, then you print mismatch and you break. Okay, so if we run this, we should not see anything, right? In case there was a mismatch, this would break at this point. So let's try it on a different set. Okay, does this make sense to everyone? What we're doing? We're checking every country individually.
Yeah, okay, this makes sense. But in the question that you had given that there is no year repeated. How do we check if there is no year repeated?
Yeah, that's the next part. Yeah, and we'll see what problem that causes. By the way, do you see a problem in this code as well? Is this correct? Let's say a country has years 1, 2, 3, and B has 2, 3, and 4. The number of unique for B is 3. The number of unique for A is also 3. So rather than comparing the number of unique, we have to actually compare one-on-one. Yeah, so let's see what it looks like. For example, let's say we have df and we say df and then country is equal to, let's say, Afghanistan, and we print out its years. So it looks something like this: 1952, 57, and so on, right? So let's convert this to a list, maybe. Yeah, okay. So we get a list of one country, and we can maintain a list of all the countries that we have. That is, let's say, as someone had did, let's say df.unique. Oh, sorry. Yeah, and then we do this. So now we have the list of unique years. Okay, and then we can get a list of years for every country, and now we can match one-on-one. In Python, you can compare lists very easily. Let's say you have 1, 2, 3. You can just write comparison with 1, 2, 4. Let's say this is true because they're identical. If they are different, it will print false. If something is a subset, it is still false. Okay, so what we will do now is, rather than total unique being a count, that is how many unique you have, you will actually store the unique years. So we have unique and then to list. So we have a list of unique elements, and now here we can have a df country is country, and let's store it somewhere else. So let's say we have this, and we will write country unique is equal to this, and rather than this we will have the list. If this is not equal to country unique, we print so and so, and we break. So if we run that, we don't see anything. Any questions? Does anyone have any questions? So let's see if it actually performs if, let's say, we did have a difference. So what we will do is, let's delete a year. Yeah, just a minute, others. Yeah, so let's say we had df underscore temp and we delete one row. For example, we had df dot drop index is equal to let's say we drop the first row, that is Afghanistan's second row. We drop that. So now Afghanistan has fewer years compared to the rest of them. So let's see what happens. So rather than working on df, we will work on df.temp for country in df.temp country df.temp df.temp, and yeah, I think this should work. Yeah, so we see a mismatch. Makes sense, right? So when we drop one of the years from Afghanistan, now Afghanistan has fewer years, so it fails the check. Okay, does anyone have any questions before we move on? Yeah, share the notebook. Yeah, so the thing is, I told you that none of the years are repeated. So what basically, why is that a problem? Let's say something is repeated. Why is that a problem? Can anyone explain? Will this code run in case we had repeated rows? Let's say Afghanistan had 2 columns of 2000, 2000. Will this run? Yes or no? Will this run correctly? Yeah, Sunit, it's better that you unmute because I don't get a notification when you guys write in the chat. Will this code run in case we had duplicates? And if not, then why not? No answers? Can't unmute. Wait a second. Meeting option. You are allowed to unmute. Yeah, okay. So the problem is, let's say you had a country, let's say Afghanistan again. Let's say we had 1, 2, 3, and 4. And then we had B, and it had 1, 2, 2, 3, and 4. Okay. It has more years compared to A. But if we switch to unique, this will have 1, 2, 3, 4. This will again have 1, 2, 3, 4. Okay. So this is a problem, because now the number of unique elements is the same, but in reality you have duplicates. So I had given you, we had assumed that none of the years are repeated because I know that, I mean, already. Now let's say you did not know that. Okay. If check for duplicates. So how do you do that? So you haven't done this in your course, so let me show you. So in Pandas, we have something known as df.duplicated, right? df.duplicated, and then you have to check which year should I check on. Let's say in this case, we call it year. So this is true, false, 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 true, true, so on. So what it does is the first appearance is false. Anytime it sees it again, a duplicate, it will set it to true. Okay. So let's say I was only working with year and I want to check whether something is repeated. Okay, so I'll do this and I can pass this as a mask and then check this. It says false. Okay, what empty does, let's say you had an empty data frame. This basically checks, do I have anything in my data frame? Okay, remember that earlier we got a mask. This is a mask, right? True or false. Everything that is false is taken away. Something that is true, those rows are maintained. Okay, so if we do a sum also, it says that 1692 rows are actually duplicates because we're only working with years. Now what we want to do is, for every country, we want to see is the year duplicated across countries. So what we do is, rather than working with only years, you work with country as well as years. So now if we do this, we see that the sum is 0. Okay, so if I remove this, we see false for everything. It says that there is no combination of a country and a year that is repeated. Makes sense? It says basically that I don't see, let's say, A and 2000 and then again A and 2000. Earlier it was saying that yes, I do have duplicates because we were only comparing 2000. Now we are saying compare two at a time. Do you see Afghanistan in 2000 again? Make sense? Yeah, I'll clarify everything at the end. I mean, where you will get the code and the meeting. Yeah, focus on the session at the moment. So can I get a raise of hand if everything is clear? Yeah, so in this problem, we covered basically three things. The first is how do you ensure basically how do you check for null values? Then we ensured that is why is number of unique elements not a good check and why you should be using actual unique elements, and further why having duplicates is a problem. OK, so let's move on to the next problem. So the next problem that we have is yeah, by the way, a quick raise of hand. I mean, are you comfortable with plotting? I did not see plots basically in your lectures. You were shown plots, but you were not shown how to plot. Okay, so empty is not clear. So what empty does, I mean, for example, let's say we had this df year. OK, so we have something inside it. Let's say I said df year is greater than, let's say, this much. We don't see anything. You see, this is an empty data frame. So if I test this for emptiness, basically empty says true. OK. Yeah, so let me show you something about plots. I mean, I'm not talking about basically Matplotlib and Seaborn as such. Pandas has an integrated framework for plotting. So let me show you an example and then I'll give you a problem. So in this case, let's say we had a data frame and what should we plot? Yeah, let's say, for example, we have df and then we take out Afghanistan from it. OK, so we have this data for Afghanistan. Let's say I want to plot the life expectancy over the years. OK, so what I do is I say df this and then I take out live exp. OK, so I have a series. Now if I want to plot it, I just write plot at the end and then you say what kind of plot do you want. So in this case, let's say I want a scatter plot. I do that, I run that. Plot kind scatter can only be used for data frame. That's actually a good point. Right. Quite X and Y. So, I mean, I'll show you this scatter plot in a moment. So what you do is, for example, you have a data frame and you say that I want to plot something. And let's say you want to plot something different. In our case, let's say we had scatter. You have to tell it, OK, what will be my X and what will be my Y, for example, in case of scatter plot. So we want the X to be, let's say, the index, maybe, no, maybe the year. I don't know if it will take that. No. Mm. Yeah, so something like that. For example, I wanted to make a box plot, and you just give it basically the data frame, and then you tell it what kind of plot do you want. Now, when you make these plots, you have the option to customize it. So in this case, let's say I want to have a bigger plot, so I can say that give me a bigger file size, let's say 10 by 10. I can ask it to label, let's say I want my X label to be, let's say, year, and I want my Y label to be, let's say, frequency, and I can also set the title. Oh, I removed kind. Yeah, makes sense. So we have box plot, we have frequency, and we have this. Yeah, you will have outliers. Yeah, so try out this. So in our data set, find out the representation of every continent. That is, how many countries are there per continent. Okay. For every continent, I mean, let's say, for example, in Asia, you will have India, Afghanistan, Pakistan, and so on. And for Europe, you will have some countries. We want to find out how many countries are there per continent and create a bar graph out of it so that we can see which country is represented more. One bar per continent. Each bar represents, not represent, shows the frequency maybe. Yeah. So the time is 8. So let's wait till maybe 8:10 or 8:05. So to go step by step, boil it down to the data that you want to be plotted, and then just call plot. Okay. Create a data set, basically a data frame that only contains these two things. Countries basically per this and the countries, and then just plot that. You can unmute if you have any doubt or if you have maybe finished or something like that.
Sir, found out, sir.
Does it work?
Yes, sir. We plotted a bar chart for each continent with the frequency of the country, sir. Is it okay, sir?
Can you repeat?
I plot the continents in the x-axis and the
Mhm.
frequency of the country in the y-axis, sir.
Frequency of the country.
Yes, sir. The number of countries, sir.
Okay, so how did you do that?
I grouped the data by group by method, and I used the n unique method, and I plotted with kind is equal to bar, sir.
Okay. Okay. So you group the data by continent.
Continent, sir. Yes, sir.
And then?
And then I only selected the country by using a square bracket, and I applied the method n unique, and I
Okay.
plotted it by dot plot method, sir.
So something like this. Okay. So let's say you have df dot.
Can I share that line in chat, sir?
Like this?
I use dot plot at the end, sir.
No, I mean, is this before plotting? Is this everything that you use?
Yes, sir. This is the same I use, but I add some dot plot on the end, sir. Yes, sir.
Mm-hmm. Yeah. Yeah. I think another way to do it might be that we pick just 1 year. Let's say because we are sure now that everyone has the same year. So let's say we pick 2002. And then what do? We take the year and we say dot value underscore counts. Will that work? df here 2002. Oh, and continent. Yeah, produces the same thing. So Tarunkar, does the second answer make sense? Same results. So there are just two ways of doing the same thing. Both are correct. So you just use plot
Sir,
at
but
the
I can't understand the second one, sir. Can you explain it?
Yeah, so in the second one, what I did first was filter out the data. Now, the thing is, you can't use all the data set at once. For example, we did not filter this out. And what we did was we said, OK, take the continent column. So this is the continent column and count how many times does every continent occur. So value underscore counts basically tells you how many times am I seeing an element. So in this case, I'm seeing Africa 624 times, Asia I'm seeing 396 times. But the problem is we have multiple years of data, right? For everyone, we have 12 years. So I will see Africa 12 times I would have seen if I would have taken only 1 year. So what we are doing is we are extracting the data for a single year and then doing the same thing. Make sense?
Since we know that each country has the same year, so we can apply this method.
Yeah, so we can do that. Otherwise, this would actually be, in fact, in case that wasn't the case, we would have to clean the data prior to doing any estimation. That is why the first thing that we did was confirm that everyone has the same years. If that were not the case, then the representation would change year after year. Yeah, okay, so now that we have the data, we should plot that. So let's go with maybe, I mean, we can try both of them. So let's say we had this. What you do is you say plot, and then the first thing you say, okay, what type of plot do I want? In this case, I want a bar plot. Okay, so if I just do this and execute, we see this. Okay, we have Africa, America, Asia, and so on, so on. Now we don't have a title. We don't have a good x-axis, nor do we have a y label. So it's best to have that. So I want that, okay, my title should be continent representation. I want my x label to be continent and my y label to be frequency, maybe. Yeah, if we run it now, we have frequency, we have continent, and we have representation. Now, do you see this text coming up? So to avoid this, just use plt.show. To use plt, basically you should import matplotlib first. So we have import matplotlib.pyplot as plt. So if you do it now, you only see the plot and you don't see basically that part. Is it clear to everyone? Yeah, for that, maybe you can consult Pandas basically. For every sorting and things like that, they will have mentioned that we are implementing this particular research paper into our algorithms.
Excuse me, sir.
Yeah.
Where shall we find those kinds of research papers, sir? Like, what is the algorithm that works behind these kinds of?
So for example, if you go to Pandas and I mean you can go for a, let's say, a particular function, let's say sort. Sometimes it even says that my sort works faster than NumPy sort or so on. You can search what sort does Pandas use, like what sort does this library use, and it will maybe point you to some article or some research paper that's basically presents an sorting algorithm, and they have implemented the algorithm into their library.
Sir, so there is a difference between people who are working behind in these algorithms and we who are just implementing for analysis purpose.
Yes, completely different. For example, as a data analyst, you don't have to implement those things. You will just use the library as is. You don't have to know them.
Okay, sir. Thank you.
Because then, I mean, there are basically different streams. There are people who work on algorithms. There are people who develop libraries, and then there are people who use libraries. So you don't have to do both of them. You will either go into developing libraries, or you will be the one who is using the library.
Okay, so deep coding knowledge is required for the former one, isn't it? To develop the algorithms, mathematical knowledge.
I mean, if you have to basically become an analyst, that won't be required. Basically, that how is Pandas sorting them, that won't be required.
Okay, sir.
Yeah, if you want to become an analyst, that won't be required. Yeah, if you want to develop your own algorithms, basically, or your own library, then you should look into those things.
Okay, sir.
Yeah. So moving on. Now try to do one thing. We see that Africa has maybe 50, America has between 20 and 25. Rather than seeing the frequency, I would like to see the fraction, basically. That is, Africa has 50% of all the countries. This guy has 20% of all the countries. So can you do that? Anyone done?
Done, sir.
Yeah, so what did you do?
Sir, simply I just divide the data by dot sum, sir. The same dot n unique dot sum.
Yeah, makes sense. Yeah, exactly. So the idea is you have the frequency. So to get the percentage, all you have to do is divide by the total number of countries that you have. So one way to do that is basically you sum this thing up. So if we plot this, I mean, if we print this out, this looks something like this. So if you do a sum over this thing, you get 142. Okay, another way to do it is that is you do df year, and then no, not year, basically country, and n unique, and it tells you that I have 142 countries. So all you have to do is basically get the total number of countries. So if you say total countries is equal to this, and then everything remains the same, you just divide it. So we say df underscore, let's say percentage per is equal to df divided by total countries and maybe multiply by 100. So rather than this, we do this, the rest remains the same. Unsupported operation for this and this. Why is it an unsupported? Oh. Again, unsupported operation. Total countries, number unique. Accepted. Integer. Oh, we did not save this. Yeah, we did not save this. Yeah.
The third line, df country dot n unique should be added, sir.
Yeah, actually, we should divide our data, right? df underscore grouped. So we have total countries, we have group data, we divide the group data by the total countries, and then we do this. Should work this time. Yeah, so this time what we have to do is we are having percentage here, and content representation is same, continent is same. So now we see that almost 36% comes from Africa. From the Americas contribute to almost 17%. In this case, for example, here we saw that they have 50 countries, but we don't know what fraction of the total is that. So it is better to plot it like this. So moving on, we want to see how the population of a country has changed over time. Okay, so can you do that? Can you make a plot where on the x-axis you have year, and on the y-axis you have population, and they are connected by a line? Simple plot. Choose a country. You don't have to plot every country. Choose one country and plot that. But try to make the code so that I can easily change your country, and in case I can also check for, things other than population, maybe how has the GDP changed over time and so on. So try to make it so that someone else can just replace one thing and the rest should be, automatically changed. So for example, rather than just population, maybe population, what are the other things? We have life expectancy, or for example, GDP. Try that. I hope all of you are trying, because it seems only a few of you are doing that. The purpose of the live sessions is that you can code alongside me and you can suggest your solutions. I will try those and maybe we can debug them together. So rather than just watching, it would be really good so that you can do it along with me. It would also be a practice for you, and you will basically gain sort of muscle memory for this syntax. At least try. At least try. For example, these things, kind, title, X label, Y label. In the beginning, you may think, okay, I have to memorize that X label is written as X label, not X underscore label, and so on. But as you do it many times over, you basically won't have to remember it or look it up every time. Any progress? Yeah, I will share it. That's what I said. The recorded sessions as well as the notebook. Yeah, so anyone done? Raise your hand if you're done. Okay, so since no one is done, the idea is we want to filter out data for a particular country, but we also, as I said, I want that if someone else wants the plot for a different country, he should not have to go through your code to do that. So we should save the country up.
I've shared a solution, but by mistake I have changed the different column life expectancy.
Yeah, no issue. Yeah, that's the thing basically. I'm saying that I mean, if you want the plot for a different column, you should not have to make much changes. So let's say we want to plot it for for Afghanistan, but we save it in a separate variable. Similarly, let's say we want to plot, in this case population, let's save it in a different variable again. So the idea is we create, let's say df country, and we say df country is equal to country. So this will extract every row that has country set to Afghanistan. So now we have df country. So what do we want to do with that? We say df yeah, by the way, yeah, that's okay. So let me check one thing. Df country, yeah, okay. So we have df country and we say plot. Now what kind of plot do we want? In this case, we actually, there is no need to supply it. By default it is a line plot, but I mean, it's okay to do that. So we say that I want a line plot. Now what do I want on the x-axis? I want you to use my index basically for that. If you don't supply it, it will, I think it will use it by on its own, but still. So let's say I say plot the year on the x-axis, and on the y-axis I want you to plot column that we set. Okay, so let's try that. Dfcou, yeah. So we have year on the on the x-axis, and we have the population on the y-axis. Again, we did not set the title, we did not set everything else. So let's do that now. So for example, we have the x label. The x label will always be the year, right? So we have year. The y label should be the same as column. We should not hard code population or something here. So we just say that y column should be column. Okay, and the title again, we will say the is, let's say column over the years. So if we plot this, we say POP, that is short for population over the years. We have the population on this case, and we have on the x-axis we have year. Now there's just one more thing. We see that the years are not aligned with what we have. Another thing is, on this line we don't know where are the data points. That is, they are connected, but where are basically the individual points? To view those, you pass in a marker. So we'll say I want my marker to be dots. So now it looks something like this. So now you can see the individual data points connected by lines. You can change the markers. For example, I can have a smaller marker like a dot, or I can have plus or x's. So you can see all the available markers in this case. So I mean, O does the job in this case. So we have this. Now the problem is, we see that these dots are not coinciding with my, basically these are called ticks, x ticks and y ticks. So my x tick is 50, 60, 70, 80, 90 and 2000 spaced by 10 years. But in this case, I would really like it if every marker had a year below it. So the way you do it is, you pass the x ticks to use. So you say, okay, I want you to use my x ticks. So you again say year. I don't think year will work, probably not. Yeah, so you actually have to pass it like this. That is the actual thing. I mean, these work. I mean, we can pass year for x and for column this, because it knows I have to look for the x and y. I can look up in the data frame. It does not expect to look up the x ticks in the data frame. So you have to pass them explicitly. So we can basically say, okay, so df year, and we can pass unique years. And now below every marker, we have the corresponding year. Okay. Another thing is that you can set grid to true. Is it disconnected? Yeah. So now you can basically follow these grid lines to identify individual points. Does that make sense? So there are two new things. One is marker and the other is x ticks. X ticks is basically these labels that I should have on my x-axis. Similarly, you will have y ticks. And then if you want a grid, it will also show that. Any confusion? Okay, so one last thing is it's showing us a legend here. That is, it says that this marker refers to population. It shows that by default because sometimes what we do is in a single plot we will have multiple lines and we may have multiple markers. So it expects that, okay, if you have multiple markers, I will tell you that this is population, maybe this is something else, this is something else. We don't want that in this case, so we can set legend to false. In fact, I think we can also part grade equal to true here. So if we try it like this, yeah, so we're getting the grade and we are not getting basically that legend. All of that can be supplied within the plot function, and all you just have to pass plt.show at the end. Okay, so let's try something else. Rather than a country, I would like to know how has the population or anything changed globally. Okay, so I want a similar plot, but rather than for a single country, I want you to maybe average out the values for the entire world and then plot that. So the time is 34. Let's wait till maybe 40 or something. I don't think we'll be able to cover everything, maybe next session. By the way, in this case, you can see that if I replace population by something else, for example, GDP per capita, and similarly, I can change Afghanistan with something else. What other country did we have? Let's say India, for example. We have India. GDP per cap. We don't have GDP per cap. Oh, we used this. df country equals country. That should be fine. Column is why. Why don't you have GDP per cap? Key error India. Albania. GDP per cap. df dot. GDP per cap. Yeah, GDP per cap. Oh. Yeah, so we can just change these two variables and control the plots below, and the title changes accordingly and the y-axis changes accordingly.
Sir, I have a doubt, sir. Um, each country have different population, so when we calculate the life expectancy, we should apply the weighted mean only, sir.
Yeah, you
Can
can. I mean, the idea in this case is just I want you to exercise plotting techniques and so on. If you want, I mean, I'm not actually expecting you to compute the weighted mean. If you do that, that's good. I'm okay if you just average them.
Can we do that with Pandas, sir?
The weighted mean. You'll probably have to do it manually, or maybe I don't know if they have a function for weighted mean. I'm not sure.
Okay, sir.
If they don't have the function, I mean, you can do it manually. Basically, you multiply by the weight of a basically the population of a country, divide by the entire sum, and so on. So the assumption, I'll mention the assumption. Assumption is assign equal weight. Yeah, so by the way, Revant, rather than making all the PLT calls individually, you can use just one plot call and pass all the arguments inside that, as we are doing in the notebook. PLT X label, PLT Y label, PLT title, so and all the braces. So that's a lot of extra code.
Yeah, I'm trying to sum all
So
the
this code is
population for a given year.
running in Spider or where?
So we're using Colab. Colab is just an extension of, it's built on top of Jupyter Notebooks.
Okay, then
Yeah,
my
by the way, Anku,
question
you were saying
was,
something.
yeah, my question was that I'm trying to, sum all the population for a given year, but this
Uh-huh.
is giving me some random output. Like, can you suggest where I'm doing it wrong?
Yeah, so the expected output, I mean, prior to plotting, what we want is we should have a data frame where the index is maybe the year, and then we have the column that we want. And for every, let's say, year, for all the countries, I want to club that. So I think these three things are done all together by using group by. If you think about it, you can ask it to group the data by year, okay? And then because it has many data points for every year, what do you want to do with all of them? Just sum them or take the mean. Make sense?
Okay, so I should be using group by. Okay.
Yeah. Group it by year, and because you have multiple data points per year, what should you do with them? Mean them or sum them or anything that you want. Then you will have a data frame like that.
Okay, thank you.
Okay, so let me show you how to do it. Actually, because we spent a lot of time in the beginning, I had extra questions for that. Maybe we won't have the time because it's 8:40. So maybe we'll go a little quicker and next time we'll do that. So what we want is, let's say we have, again, we want the country to be a variable. In this case, let's go with India. And again, we want the column to also be a variable. So let's say we have population. And what we will do is, yeah, in this case, actually, we are doing it globally. We don't need these. We only need the column. So we have df, and then we will group our this thing by our column. And once we have that, what do we want? We want the no, we want to group it by year. Yeah, we want to group it by year, and then we want to take out our column. And what do we do with that? We want the average. So let's see what it looks like. Yeah, so in 1952 the average population looks like this. In 57 it looks like this. So we have this code. Another thing to note is this thing is not a data frame. It is actually, I believe it's a series. Yeah, it's a series. So you should keep this in mind. For example, let's say you have pandas and then you do here, for example. This is a series. When you pass a list of list, it returns a data frame. So this is crucial. In certain cases, it expects you to pass a series, it expects you to pass a data frame. So when you want a data frame, ensure that inside df, you are passing a list. Okay, so for example, if you do year like this, you are supplying a list, so it will return a data frame. If you supply a single string, it will return a series. So at some point it may matter. Okay, right now it doesn't matter. Both can be plotted with dot plot, a series as well as a data frame. But if you need it, it's better to go with two basically braces for a data frame. So we have this thing. So let's go with a data frame, and then we have a mean. So notice that in this case, we also get a label pop. Last time we did not have that. So what do we do with this? We again want to plot it. So what kind of plot do we want? We again want a line plot. We also want markers in our plot. So let's see what it looks like. Yeah, so the population is increasing linearly over the years. So again, what do we want? We have this. The title should be column, average column, maybe average this over the years. The X label should be year. The Y label should be our column. We want a grid and we don't want a legend. Is there anything else? Yeah, just X ticks. Yeah, X ticks. So our X ticks should be again, I think we can just use years. Yeah, year unique. So instead of population, if we say life expectancy, what was it? LIFE-EXP. Average life expectancy over the years, year life expectancy, and so on. Okay, so we have this. That would be pretty much the same. So let's do this.
Excuse me, sir.
Yeah.
Sir, can you please give us some of the questions for as a homework for practice?
I mean, as if we are left with any questions, I mean, I have planned, I think 6 or 7. If we are left, if some of them are left out, I mean, I can give them to you. Otherwise, I mean, I haven't prepared extra questions. I mean, you can Google them. Yeah.
Okay, sir.
So let's say we want to find out which continent has the highest or lowest. I mean, we can pass anything. For example, in this case, let's say population. It can be life expectancy, same as before. Keep that as a variable, or the GDP. So this time you don't have to plot, you just have to find it. Okay. Find out which continent has the highest or the lowest population. Again, to aggregate the countries, it's your choice. I mean, you can either use the average or you can use the sum. I mean, in the real case, I mean, we'll have to think over it because we have different number of countries, we have different population. But for the time being, I mean, to explain the code, it's your choice. You can go with some of the countries, you can go with the average of the countries.
Excuse me, sir.
Yeah.
Are your lectures available on YouTube? I mean,
Yes.
I missed some initial content, so I watch it.
Yeah, so
Can
after the lecture, I will upload. Yeah.
can you share the your YouTube link
And
if
I will
possible?
share both of them. Yeah.
Thank you.
At the end of the session, I'll share both of them.
Sir, I have a doubt, sir. I grouped the data and used the method max and min, but it displays up to 5 continents, sir. How to
So,
reduce it to one, sir?
so for example, you have DF and you group by
Continents, sir.
okay, and then
I use the group data on population and use the method min, sir. Minimum MIN. It displays up to 5 or 4 countries, sir. So I don't know how to reduce it to one.
I mean, it's not showing any countries, right?
The continents, sir, sorry. How to reduce it to only one row?
I mean, you can again take the min over these, right? For example, if you do a min again.
Okay, sir.
Sir, you shared the lecture on Gmail or where?
I'll share the lecture where?
On Gmail or at which place?
No, I'll upload them to YouTube.
A link?
Yeah, the link I'll share right now. At the end of the session, I'll share it in the chat. If we try GDP per cap, that is Oceania. ठीक. Okay, so let me show you how to do it. So we want to find the continent that has the highest or lowest, let's say in our case, population. So let's say our column, we set it to population, and we want to find the one with the minimum. So obviously we'll once again use a group by function. So what group by does is everywhere that I have continent set to Africa, that will fall under one group. Now I have to supply a function to aggregate all of those. So in this case, I'll say give me the minimum of every row that has continent set to Africa. So let's say we have DF and we say DF and country, in fact continent. We say DF dot group by, and we group it by continent, and then we are working with our column. So we have this. Now what do we want to do with everyone that has continent set to something? So we want to take the minimum or the maximum if we were going for that. So we have the minimum. If we print that, we see these, that is the minimum population in entire Africa is this much basically over all the years. Okay, we're not supplying any one year, it is over all the years. So we can even supply the year, but that's okay. So we have this, we have this, we have this. Now how do you find the minimum over these? If you again call minimum, you will get the minimum population, but you don't know what was the continent. Okay, so to do that you use IDX minimum, that is index of minimum. So this tells you that Africa has the lowest population over everything. So if instead of min, we can also use max. So in fact, we should not use min. I think we should use sum or mean because we are aggregating. So if we do a max and we print this and we print this, so we have Oceania has the lowest population and Asia has the highest population as expected. So instead of population, if we let's say try it GDP per capita, we see that Africa has the lowest GDP per capita and Oceania has the highest GDP per capita throughout the years. Okay, because we did not restrict it to basically a sum year. We can also do that. So for that, we will pass DF year at this point. So we're taking all the years at once. Make sense? Does anyone have a confusion? No? Okay, moving on. So you read about skew in your class. That is, you plot the distribution and you see, is it so that you have a bell curve, that is the metric is evenly distributed across the data points, or is there, or are there some values, that is, let's say very few people have very, let's say in our case, let's say a very few countries have a high GDP and many countries have a low GDP. So you will have a skew in that case. So let's say we want to measure our skew in terms of, let's say, population, that is population skew. So what we want to do is find the population skew in, let's say, Africa. So for every country in Africa, we will basically plot the population and we will see, are most people, basically are most countries in Africa, do they have a very small population or do they have very large population? So this wasn't taught in your lecture, so let me just show you how to do it. Okay, so what you will do is, first we will take out Africa from this. Let's say we have DF Africa, DF continent Africa. Yeah, so these are the countries where we have Africa, and then we want to find the skew in population. So let's say we say, give me let us say only the population. Okay, and we will also restrict it to a particular year. So to give two conditions at once in Python, now this is important, you supply them as like this. Okay, so it is important that every condition should be inside a tuple and they should be separated by and. Normally in Python, you would do something like this. For example, if you had, let's say, x is equal to 10, you will say if x is greater than 0 and x is, let's say, greater than 100. You cannot use and in Pandas. In Pandas, you are expected to use this type of and. The second thing is, every condition should be within tuples for Pandas to use. Otherwise, it groups them in an odd way. Okay, so what we do is we take the continent Africa and we set the year to 2007 and we only want the population. So this is the population. So if we want to compute the skewness, we just pass skew, we just call skew on this. And this is the skewness of this basically Africa. If let's say we wanted to do the same thing for, let's say, Europe, we have the skewness for Europe. Now, let's say we want to plot these. How would you do that? Now, to compute skewness, if you have seen, people usually draw a distribution. Okay, in distribution, you sort the data and then you do a continuous thing if you had a function. But in our case, because we have discrete values, we will go for a histogram. Okay, you will say, okay, how many people have population between this and this, this and this, this and this, and you will get basically bars, individual bars, and then you will get an idea of the skewness. So again, we will reuse this part. So let's say we have this and we will say plot kind is set to hist, and let's see what it looks like. Yeah, and we can set bins equal to 10 and we can set y equal to population. Yeah, so it looks something like this. Okay, so if we do the same thing for, let's say, Europe, we see for example, in this case, we see that they are both actually heavy, I mean skewed, but we can see that in case of Africa, the pillar here basically is quite significant compared to these. I mean, we see, I mean, they actually have, I mean, comparable heights in somewhat comparable height. Therefore, the skewness in this case is 1.5, and in this case it is 2.8. Okay, does that make sense? So if we do it in the same cell, so similarly, we can do it for Europe. Yeah. So what else do we have? Yeah. So another way to look for skewness is to use a box plot. So in a box plot, what you do is, as you would have seen in your lectures, you have the median and you have 4 quartiles. Okay, so you will use the exact same code, only the kind would change. So let's say we will do, in this case, let's say country continent is equal to Africa, and we will I think this should be here. So let's say we have continent and column, in this case let's say GDP per capita. So we will have this, and y will be column, kind in this case will be box plot. We don't want a grid, we don't want a ledger. Yeah, so we see the GDP per capita for Africa. Okay, if we do the same for, let's say, Europe, it looks quite different compared to this. We have a lot of outliers in case of Africa, and the median is close to 2000. In case of, it's not actually 2000. Yeah, the median is at 2000. In case of Europe, the median of GDP is at 30,000. The minima is at 10,000, and here the median is at even the max, actually the third quartile is at 8,000. So this is another way to compare two distributions, and again we see that both are skewed. In fact, this is more skewed because we see that the median is actually quite low. It is at the bottom of the graph, but 50% of the data is above it, and the median is quite low, so we have a skewed distribution. In case of Europe, the distribution is relatively okay because the median, I mean, if we see that 50% above and 50% below, we don't have basically that many outliers and so on. So one last thing is that, let's say we wanted to compare the GDP of Africa and that of Europe side by side, rather than scrolling like this. I want to do it side by side. So the way to do it is you create subplots. So in Python, the way you do it is you say plt.subplot, and you have to supply 3 numbers. So 1 by 2 by 1. What does 1 by 2 by 1 mean? It basically says I want 1 row, 2 columns, and right now I am working on the first basically cell. Okay, so the second one would be plt.subplot 1 by 2 by 2. That is, use the same grid, that is one row, two columns, and now I am at the second column. Okay, so if we do this, and I can just copy this over. And we, for example, do this, and then we do a plt.show. One by two by one by two by two. In different columns. plt.subplot. Plot this plt.subplot 1 by 2 by 2 continent is set to this plt.show. This should work. plt.subplot plt.subplot. Auto remove overlapping axis deprecated. So if I do
Sir, I have doubts, sir.
yeah.
In the box plot, the minima and maxima are represented by a what kind of, it's a line, but the candle-like structure, what that does it represent, sir?
A microphone. Any.
I can see
Yes.
the median and the lower range and upper range. The other, the candle-like sector, what does it represent?
Yeah, I mean, it first, I think, explained in your lectures, right? So the green line is the median. The edges of the boxes are the 25% quartile and the 75% quartile. These are called whiskers, basically. Everything that falls between these whiskers is basically the interquartile range. Outside these whiskers, these are considered outliers. So this is usually 1.5 times the distance from median to the 75%, and similarly this one is 1.5 times median up to the 25% quartile. Beyond that, they are considered outliers. So in this case, you don't see any outliers. In this case, you see outliers. Does that make sense?
Oh, yes, sir. They are simply Q1, Q2, and Q3.
Yeah. Q1, Q2, Q3, Q4. Yeah. Yeah. So in this case, I don't know why it's not working. It should work. I mean, the expected behavior is that you would see one plot here and the other plot here. I don't know why we are getting so many plots. 1 by 2 by 1 by 2 by 2. This is this, this is this. So I think it's past 9. I'll fix this and maybe push it to GitHub. So let me share the links with you. So for the code, go here, and for the recording, go here. Can you confirm if both of the links are working? Yes. Yeah. So subsequent lectures will also go like this. So whatever you study in your class, design questions around them, and then we'll try to solve them together. Okay, so let me stop
Yes,
recording.
sir. Yeah.